In this video, we're going to take a look at another example of setting up a linear programming problem. So let's say that a bookstore at a university wishes to produce two different types of coffee mugs. For lack of imagination, the type A coffee mug and the type B coffee mug. Each type A mug will result in a profit of $3, and each type B mug will result in a profit of $2.75. Furthermore, we know that a type A mug requires 7 minutes on machine 1 to make it, and then 3 minutes on machine 2. What are these machines? I don't know. Maybe the first one is making the mug itself, and the second one is doing the painting. Putting the, I forget what the terminology is, maybe they're made out of ceramic and putting ceramic glaze or whatever that term is on there. And then for type B, 4 minutes on machine 1 and 5 minutes on machine 2. There are 12 hours available on machine 1 and 10 hours available on machine 2. Maybe because they're being put to use for other things, whether it's making them for the bookstore or other places. How many of each type of mug should the store make to maximize its profit? Now, we're not going to actually answer the last question. We're just looking to formulate the linear programming problem, which could then be later on solved. And so we need to write something about maximizing profits and subject to the constraints given. Okay, so we could, before writing out the linear programming problem, set up a table. Before we do that, first of all, we need to recognize, since we are maximizing profit and we're talking about how many of each type of mug, then we need to name our variables. And without writing a full paragraph the way we've got in the statement of the question, we should have a brief but specific description of what those variables are. So I'm going to let X be the number of type A mugs. I'm not just saying X is the type A mugs. I'm saying it's the number of them. And Y is the number of type B mugs. Why have I gone into the specificity of type A mugs? How many there are? Well, I could create a similar question where instead of it being the number of mugs, I could be trying to figure out what cost to sell them to the customers for. And, be a very similar question. I would know how many I'm going to make in that case, and I'm just trying to figure out what price to set to maximize profits. So let's see here. What would the table look like? Once I've made the decision of what the variables are and what I'm naming them, then I could set those up in columns and go across rows then to talk about the objective function that I'm going to maximize. We're getting a profit of $3 from mug type A and a profit of $2.75 from mug type B. We have that on machine 1 for mug type A, there are going to be 7 minutes needed, whereas we need for mug type A on machine 2, 3 minutes. Then for mug type B on machine 1, we're going to need 4 minutes on machine 1 and 5 minutes on machine 2. What I've not addressed yet is the bit about the time available. So we have for machine 1, we've got 12 hours available on machine 1 and 10 hours available on machine 2. Notice those are in hours where the rest are in minutes. So if I were to convert everything to minutes, instead of having a mess of trying to convert these things in minutes over to hours, 12 hours times 60, 720 minutes. And 10 hours times 60 minutes per hour would give me 600 minutes. All right. So let's take a look, after having set up this table, how that's going to turn itself into writing the linear programming problem. So we have to state what's being done to the objective function. We want to maximize that profit. I've given profit a name, besides naming the variables about how many of type A and type B mugs. I'm also naming the profit P, so P equals, and then I've got 3x plus 2.7y. No inequality there. And then we have to state subject to, which some instructors may allow you to abbreviate as S.T. So S period, T period, and 7x plus 4y less than or equal to 720, because, well, you may wind up using all of machine 1's time, but you may not. The most profitable arrangement here may leave you with some slack time on machine 1, or it could be on machine 2. So it's not going to be exactly equal to, it could be less than or equal to. Finally, 3x plus 5y less than or equal to the 600 minutes. And although it's not stated, you're obviously not going to make a negative amount of mugs of either type. And so we have non-negativity constraints to state here at the end. You cannot forget that. Hope that helps.